Today we are going to start electric motor. We know that the current carrying conductor kept in the magnetic field experience a force. Okay, this much we know about the electromagnetism. Now I must tell you one thing, that when I was in school or when I was in college, I was very much confused about the electric motor or the working of the electric motor. I know that if the current carrying conductor is rotated in the fixed magnet, then it will experience force, a torque will be generated and it will rotate. My question was, then how that current carrying conductor, that means the wires, do not get jumbled when they rotate and the battery and all this power supply etc. are fixed? Why they not get jumbled? That was my question. I have come across many students who do not understand this concept properly. Okay, and they get confused, and if you are confused or if you simply mug up or by heart the principle and the working and the construction of the motor or generator, then you may not able to reproduce it in your exam. You must understand the function of it. Okay, you must understand it. You should not only mug up that. Okay, so before going to this electric motor, let me give you one very simple example where the electricity and other things are not generated, but still the motor is there, or I can say some wheel is rotating. In olden days, such wheels or the windmills, like you see the windmills, the water mills are there. Okay, what they do, if this is a river, they used to build a mill somewhere here. Okay, and big circle is there. Okay, with the flaps like this. Those of who are belong to some villages or those who have the native places at some village, they must have seen such things, where in olden days the water is extracted from the wells with the help of bullocks and this big wheel, and some pots are attached to this. What, suppose this is not a river, this is a well. What they used to do? They used to rotate this wheel with the help of some means, by bullocks or the man himself rotate it. What happens? As this wheel rotates, it takes the water from the well, and when the wheels go here, they pour all the water here somewhere, something like this, and ultimately what will happen? The water comes here, from here it will drop here, and from here the water goes wherever we want. Okay, but this is a mechanical process. The wheel is rotated by some means, maybe by bullocks or human beings. Okay, so the water is extracted from the well, river, lake, whatever it is. Okay, just understand this principle. Every time this pot is empty here, the second time pots come here, it takes the water in that pot, it goes up, it emptied that water here on some tunnel, and then the water goes to wherever we want. Okay, now let us see one step further. Now suppose I want to run the wheel with the power of flowing current. What will do? Suppose this is a river. Okay, what I will do? I will put some wheel here and the water is flowing in this direction, and here some blades are attached. some blades like these are attached. Okay, what will happen when this blade comes in contact with the flow of current? What will happen? This flow of current will push this blade. It is mounted. Okay, this will push this blade and this blade will go forward, and since this wheel is on the axis, it will rotate. By the time of rotation, now this wheel will come in contact with the water. Again water will push it, it will go up, and another blade will come in contact of water. And what will happen? Because these are mounted on the good ball bearings, what will happen? It will have a flow. By its inertia, it will have a flow, and will go on rotating till this river is flowing, because the river current is pushing the blades of the wheel, and so this wheel is rotating with the full speed. That speed will depend on the speed of the current, right? And this will go on rotating till this river is flowing, right? Now if you attach a big rod to this wheel, this rod will also move, just like your motor moves, motor axle moves. And with the help of this, you can attach anything here. You can attach belt and run some mill, or you can do anything with that. Okay, have you understood this principle? The first, it is pushed, the second comes in contact, push, the third blade comes in contact, pushed, and the process goes on. Okay, now the similar thing is used in case of electric motor. Now let us see the actual figure, a simple figure of electric motor. Now suppose this is a horseshoe magnet. This is the fixed magnet. Now we require some current carrying conductor in between. Now I have taken just a single coil, just single turn I have taken, but generally instead of this a full winding is there, coil winding is there. Okay, I have taken a single turn. Now this coil must carry a current. Okay, so these two ends must attach to current. So let this my power supply. Okay, now you know that power supply is fixed, these cables are fixed. Now suppose when this key, the circuit is closed, when the circuit is closed, what will happen? The current will flow through this coil. Okay, the magnet is there, current carrying conductor is there, it will experience some force, and because of that force it will turn. Okay, on this side, if the force is on this side of the force is acting downwards, the opposite side the force will acting upwards, because we are applying here the Fleming's left hand rule. The Fleming's left hand rule we are applying. So what will happen? The force, suppose here it is upwards and here it is downwards, it will turn like this, 180 degrees, half turn. When it changes its side, what will happen? Now this will have the downward force and this will have the upward force, and it will go on winding, it will go on rotating. But what about this? This is fixed. If this much part is fixed, what will happen? This coil will be twisted. When it goes on rotating, it will get twisted. So that should not happen. So let us see, to avoid this twist, what construction is done in case of the motor. We have one axle here. We have one axle here. Okay, and on this axle there are two slip rings. One slip ring is here and one slip ring is here. Now both the slip rings are nothing but the semicircular portion which are fixed to that axle. One is from this side, one is from this side, one is from this side, and both are separated with each other. Both are not in contact with each other, they are insulated. Okay, have you understood this much? Now this axle can rotate. Okay. Now for this slip ring, this part, the one end is attached to this slip ring and one end is attached to this slip ring. Okay. Axle is there. When this gets turned, when this is rotating, the axle will also rotate. Okay, because these two are separated with insulating materials. So once this will be positive, this will be negative, whatever it is. So now there is no hurdle. As soon as this starts rotating, your axle will start rotating. This is the shaft of motor or the axle. Okay. Now how to give the power supply to this? How to give power to this? Very simple. What we do, we have some sort of power supply here. Okay. Now if you fix this power supply to here, if you fix this wires to this axle, what will happen? When the axle will rotate, these wires get jumbled. So for that there is a carbon brush attached. A brush is attached. Now what do you mean by brush? Suppose this axle is rotating, the brush is a carbon material, a small piece, black piece, which will touch this slip ring, which will touch this slip ring, and once the slip ring is touched, the power circuit is completed. Now see. Now see here. As soon as the circuit is closed by the key, what will happen? The power electrical current comes to here through carbon brush, through slip ring. It will go here from this end, from here now up to slip ring. Now carbon brush is touching the slip ring, and again from slip ring to carbon brush, and the circuit is completed. Okay. This carbon brush is always spring loaded and it is always attached to it, and this carbon brush warns out. It always touch the axle or touch the slip ring. It will always touch the slip ring, and by the time, after some time, this carbon brush will be worn out, and at that time you have to just change the carbon brush. Okay, once the carbon brush is worn out, you have to just change the carbon brush. That's all. Okay, so now from here the circuit is completed. The axle will start rotating very fast. Okay, let us see the construction, the names again. This we call as armature coil. This is fixed magnet. These are brushes. This is slip ring. Now this is the general construction of the electric motor. Okay, as we want the current conductor to be placed in magnetic field, we have fixed magnet. North pole is here, south pole is here. Now we have the current carrying conductor here. We have the power source. Okay, we have the axle. This is the axle of the motor which will rotate. Now you have to understand this part very carefully. Okay, this is called as split ring, and this current carrying conductor is attached to one end and second end is attached to this slip ring. Now what is slip ring? If we take one ring and we just mount over here, what will happen? This is a complete ring. So instead of this complete ring, what happens? They cut this ring into two parts. We have the ring. Okay, they cut this ring into two parts, two halves. Okay, and both of the halves are insulated. They are not in contact with each other. They are not in contact with each other. Now this is called as a split ring because they are split that ring. Now this one part is fixed here on one half and second part is fixed here. Okay, and to this split rings, this coil is connected. Two endpoints of the coil are connected to split ring. Now consider that power source is not there. Okay, what will happen? As soon as this will experience force, it will start rotating, axle will start rotating. Okay, but we should give continuous power supply or continuous current to this coil. If it is attached to split ring and if you connect the wires directly to split ring, what will happen? As it turns, all the wires will be here, will also start rotating and will get jumbled. So we want something, we don't want this green part to be moved at all or turn at all. Only this much part should be moved. So what we do, instead of permanently connecting this wire to this split ring, what we will do, in between we will put brushes. These are carbon brush. Different grades of carbon or graphite are there. These are the carbon brushes. Now these carbon brushes are spring loaded. Okay, and those are very brittle. They worn out very fast. You know that when you're writing with the pencil also has a graphite. After some time it worns out and you have to sharpen it again. The brushes are exactly like that. Those will touch the split ring. When the axles moves very fast, what will happen? Because of the friction, this carbon brush is softer material than your axle and split ring. It will worn out, but it is spring loaded. So till that length is finished, it will push and be always in contact with the split rings. At some point it will totally worn out and you have to change that. Okay, so this conductor or this connection is not directly given to split ring, it is given to brushes and brush will touch the split ring. Okay, so for the one turn, suppose this is negative, this is positive. For the one turn, this point CD is negative, but when it turns and this split ring will come at this place, what will happen? Now AB will become negative. Right now AB is positive, CD is negative. One half turn is there. Once it takes the one half turn, what will happen? The polarity is reversed and again the forces, the direction of forces will be reversed. Right? Now let us consider this. Now the power supply is attached, the key is closed, current is flowing, so it will experience the force. The direction of force will be given by the Fleming's left hand rule. Let us consider that this force acts downwards and this force acts upward. Okay, what will happen? It will take, that coil will take one half rotation. Okay, it will take 180 degrees rotation, half turn it will take. At this point CD is negative, it is taking upward. Now CD will go upside and AB will come here. Now CD is positive, AB is negative. Now for the second turn, again now CD will be pushed downwards, AB will be pushed up, and now till this power supply is supplying the current, this will go on rotating in the same direction. Clockwise or anti-clockwise, that depends on the power supply, how you connect the power supply. You can reverse the motor, you can forward the motor. You can run the motor in clockwise direction or you can run the motor in anti-clockwise direction. So this is general principle of electric motor. Now understand one more thing. Suppose this power supply is not there. Okay, and if you rotate this by some means, if the power supply is there, current is carrying through this, what will happen? It will rotate. But if it rotates, what will happen? Current will produce, and then we will call it as generator. Okay, we are going to see the generator in detail But let us see the electric motor in detail first. So let us understand this again. What is electric motor? Electric motor just converts the electrical energy into mechanical energy. It works on which principle? Whenever the current carrying conductor is kept in the strong magnetic field, it will experience a force. Okay. Now, very simple thing. This is called as armature coil. Armature coil is nothing but on the circular rod or the square rod, lot of copper coil is turned. Okay. Here I have just shown a single turn, but there are a lot of copper coil, copper windings are there. Now these are the carbon brushes to which the power supply is attached. These are the split rings attached to the axle which are insulated from each other. They are not in contact. A simple ring is there, splitted in two halves and attached here. And armature coils, two ends of the armature coil are attached to these two split rings. Okay. Whenever the power supply starts, the current flows through the conductor, it will experience force. The direction of force will be given by the Fleming's left hand rule. At first, the part which is near to the North Pole will experience a downwards force, and this will have the upward force. Two equal and opposite forces will produce a torque, and it will turn around its axis, which is its axle. Once it completes 180 degrees, the poles are reversed and it will again act the similar equal and opposite forces, and this process will go on continue, and this motor will turn, or we say that the motor is running. Okay, as long as this power supply is there, the motor will run. Now what will be the speed? The speed of this axle will be measured in RPM, the revolutions per minute. Now this revolutions per minute, or the speed of the motor, is dependent. How fast a motor will run will depend on how strong this magnet is and how strong this current is. Okay. Now in actual motor, these parts are properly lubricated. Okay, so that the motion must be very smooth. There should be minimum friction or minimum external acting forces on this motor. Okay. Now where do we use the electric motors? No, this is a DC motor. Why? Because we are supplying DC power, because here we have the direct current. DC power supply we are giving, so this will be called as the DC motor. Now what are the uses of electric motor? The electric motor is everywhere in our house. It is there in the washing machines, mixers, ceiling fans, everywhere the electric motor is used. Okay, even the toys, small cars are having electric motor in this. So the uses of the electric motor are innumerous. Now, as I told you before, let us see the reversed process. That means if the power supply is not there, and by some means this is moving only very fast in this magnetic field, what will happen? The reverse action will take place, and now the electricity will be generated.